Now we will take a look at part B of problem 5.2. So in part B, we want to find an approximation. So approximate the 95% quantile in the distribution of x, where we assume that mu is equal to 2, sigma squared is equal to 1, and lambda is equal to 50. So what does that give us? Well, first of all, we have to find the formula that gives us the approximation of the quantile. And this is actually the only place in the notes, really, where quantiles are truly mentioned. So what we're looking at is the formula on the bottom of page 57. And to be completely honest, this exercise is a little bit pointless because it's just finding the formula and plugging everything in. But we're going to do this anyway. So let's just write up the formula. So the quantile, the 95% quantile U sub 0.95 is approximately equal to the mean of x plus the 95% quantile in the standard normal distribution multiplied by the variance of x, and then what do we have? Plus 1/6 of the 95% quantile in a standard normal distribution. We have to square that, then minus 1, and multiplied by the centered third moment, which is given as such. So I take this to the centered third moment, divided by the variance of x. Phew, that was long stuff. So what do we know? Well, we know that we can substitute this using this here, right? And we also know that we can substitute the variance of x using this here. So probably we need to write down what the mean of x is and just figure that out before we continue. So the mean of x is given as the mean of x given n, right? And we actually have the mean value of x given n, since given n equals some value n up here, then x is just the sum of n id variables yi. So the mean of x given n is equal to n multiplied by the mean of yi, which is just the mean of y, we'll call it. So the mean of x is equal to the mean of n multiplied by the mean of y. And that will probably be okay useful in our calculations. So let's see, what are we missing? We have the mean of n, we have the mean of y, and then we also need to figure out what is the 95% quantile for the standard normal distribution, and you can find that on Google or in a table, or you can use R to find that, and the value that we get is 1.645. I think the command in R is called qnorm, so if you just enter qnorm 0.95, then that should give you something useful. So we have this, we have this, we have this, we have this. Now we should probably also try and find some numerical values for the mean of y and the mean of y squared and the mean of y to the third, so for the different moments. So let's just start by writing up the general expression for the kth moment in a log normal distribution. So if y is log normally distributed, then its kth moment is equal to e to the k mu plus a half sigma squared. Is that right? think we're missing a k-square here. There we go. So the kth moment of a log normal distributed random variable is given as such, which then implies that the first moment of y is equal to, well, we already know the first moment of y is e to the mu plus sigma squared halves, so that wasn't that hard. However, the second moment is a bit more interesting because then we have e to the 2 mu plus 2 squared divided by 2, that gives us 2 multiplied by sigma squared. And we have that the third moment is equal to e to the 3 mu plus k squared halves, and here k is 3, so we have 9 halves multiplied by sigma squared. So we have these three different moments here, and we can take our numerical values, mu equal 2, sigma squared equal to 1, and plug that in here, and then we get certain numerical values, and these numerical values are, they are 12.2, 403.4, and 36,315.5. So basically what we do now is we can just substitute everything that we can into this formula. And also recalling that lambda is defined to be 50 after you've just plugged in all of the different values that you have that are relevant here. You should arrive at the fact that the 95% quantile in the distribution for x is approximately equal to 868.3. So just plug in the values yourselves. You have that the mean of x is given here, that the variance of x is given above, that this is given from above, this is given above. So just enter all of the values and you are done.